So welcome here. We are going to see types of numbers. Right? What we are going to learn here? Types and classification of numbers, basics of number system, and conceptual questions to get more clarity on this. So let's get started. Now, let us start with this. We all know what natural numbers are, right? So natural numbers starts from 1, 2, 3, right, and so on till positive infinity. Now, try to understand 3.5 is not the natural number, right? So anything which is in decimal form is not a natural number. So 8.0 is definitely a natural number, right? This is a natural number, right? uh, Minus 3 is not a natural number, right? So natural number starts from 1 2 3 till positive infinity, and decimal form numbers are not natural numbers, right? So all the natural numbers are also whole numbers, right? So apart from these natural numbers, numbers has this zero extra. That's it, right? So whole number starts from 0 1 2 3 and so on. Okay, these are whole numbers. Natural numbers are 1 2 3, whole numbers are 0 and so on. All whole numbers are integers. Apart from whole numbers, integers can also be negative, like this. Integers can also be negative integers, right? So again, try to understand, integers are also not in the decimal form. So this is not an integer, this is not an integer, but this is an integer, right? This is an integer, right? This is an integer, right? So the numbers which are not in decimal form are said to be integers, right? So if I want to write down on the number line, right? So 0 1 2 3, right? So these are natural numbers, these are whole numbers, and these are integers. All these are integers. So try to understand, till this circle decimal part is not acceptable, right? Not acceptable. Now, what are rational numbers? So rational numbers consist of all the integers. So all integers are rational numbers. Apart from the integers, apart from integers, rational numbers can also be written as terminating decimals. Terminating decimals. What is terminating? Terminating is stopping, ending, right? Ending decimals. So what is ending? What is terminating? 3.5, it is terminating decimal, right? 8.453, terminating decimal, right? Terminating decimal. So 8.0, terminating decimals. That's why all integers are rational numbers. So these terminating decimals are rational numbers. Okay, and apart from this, even if the decimals are non-terminating but of recurring type, let's say 1.3333, so I can say the given decimal is non terminating but of recurring type, because 3 is recurring. I can write this like 3 bar as well, where 3 is recurring, right? So this is also rational number. Whenever your decimals are non-terminating but of recurring type, it becomes your rational number, right? So for example, 83.938938 and so on. Here this part is recurring, and so the given decimal is non-terminating but of recurring type, and so it is rational number, right? Try to understand. So technically rational numbers can be written as p by q format, right? Because we can write this in fraction form. All these things can be written in the fraction form, right? 3.5 can be written as 35 by 10, like this. So rational numbers are of p by q format where q is not equal to 0. This is a technical expression of rational numbers, right? Technical expression, and this is definition of rational numbers. So I hope you're understanding. So all rational numbers would consist of integers like this, right? And all integers, as we know, are whole numbers. So all these are integers as well. Apart from this, we have negative integers as well, right? And so this is how the rational numbers we are going to play in aptitude, on this circle, right? On this circle only predominantly. Now, what is irrational number? So the numbers which are non-terminating and non-recurring as well, right? So for example, if I write 3.832542 whatever, right? And so on, so on, so on. So the given decimal is non-terminating as well as non-recurring, and so it is an irrational number, right? So if the decimal is non-terminating and non-recurring, it is an irrational number, right? So the most favorite example is pi symbol, right? It is an irrational number. Now again, try to write down this. Square root of all non-perfect squares, square root of all non-perfect squares are irrational numbers. For example, root 5, this is not a perfect square, so irrational number. Root 6, 6 is not a perfect square, so irrational number. Root 8, not a perfect square, so irrational number. Root 9, is a perfect square, and so it is a rational number. Root 9 becomes 3, and 3 is a natural number, so a whole number, so an integer, so a rational number, right? So 3 cannot be, under root of 9 cannot be an irrational number. So I hope you're understanding. Similarly, under root of cube root of all non-perfect cubes are also irrational number in this way, right? So you can see this number as well is irrational because it is non-terminating and non-recurring as well. Even if you simplify or on this on let's say scientific calculator, right, you'll be getting this particular expression as non-terminating and non-recurring as well. And so under root of non-perfect squares are always irrational number. And so set of rational and irrational numbers becomes real numbers, right? Real numbers. And here, if you want to write, right, if you want to complete your knowledge, real numbers and the other is imaginary numbers or complex numbers, what you can say. This is not part of our syllabus, by the way. Imaginary numbers. And so this becomes our number system. This becomes our number system. So basics of number system. I hope you're understanding this point very much clearly. I want you to revise, recap, and take the notes of this, right? This is foundation of our aptitude, or that what we are doing here, right? Great. Now let's have some quick exercise, conceptual exercise. Identify the types of numbers. So if I can see here, this is non-terminating but recurring decimal, non-terminating but recurring digits, and so I'll say this is a rational number. This is a rational number. Because why? Because rational numbers are non-terminating but recurring type, that can come under rational number. 0, I can name 0 as whole numbers, and so it is a integer as well, and so it is a rational number, and so it is a real number, right? So it is a real number because all rational and irrational numbers becomes real number. So 0 can be written like this, whatever you want, right? -3 is not a whole number, but it is an integer. So if it is integer, it must be a rational number as well, because all rational numbers are integers, right? That is what we saw. So rational number, and so it is a real number as well, right? 8.8387. So I cannot see anything repeating, anything recurring here, and so it is irrational. Why irrational? Because non-terminating and non-recurring decimal. Irrational, and all irrational are also real numbers, right? So I can write in any way. So I hope you're understanding basic thing here, right? So I hope this is pretty much clear to you guys. So what next we are going to say is classification of natural numbers. Very interesting thing this will also.